Hi everyone. So to solve recursion methods, we have four methods. Find the time complexity for recursion method, we have four methods, which is iteration method, substitution, and subtree method, and master's theorem. So I'll explain the substitution method. Iteration method, it is not in our syllabus. For that also, I'll forward the video. So here we can see substitution method, just like if the problem is like t of n into t of n minus 1 in substitution method, first step is to guess what it would be. For example, if problem has n by 2, we should guess the problem is divided by 2, so it will be like log n order, the time complexity. Here for this kind of n minus 1 plus n, we should guess like n square, the time complexity will be in the order of O of n square. So our induction goal is we are going to prove t of n less than or equal to cn square. Our guess is O of n square. The induction goal is to prove t of n less than or equal to cn square. So induction hypothesis is like the problem. Uh, so in problem we have t of n minus 1. To apply the cn, if t of n is cn square, then t of n minus 1 is cn minus 1 the whole square. So proof of induction is we are expanding this c of n minus 1 in this t of n minus 1 as c of n minus 1 square, we are applying in the problem. T of n equal to this one, so t of n minus 1 equal to c of n minus 1 the whole square. So a minus b the whole square formula is a square minus 2ab plus 1 plus b square. So here n square minus 2n plus 1. If we take it inside cn n square, this thing, we wanted to prove t of n less than cn square, no? So here we have cn square term and minus 1. If we negotiate some positive number, then obviously, for example, if we are removing minus 1 from c of n square, then the t of n is less than or equal to c of n square. So we are going to say like c will be, so 2cn minus c minus n greater than or equal to, should be greater than or equal to 0. So if we take out c, it will be 2n minus 1 greater than or equal to this minus n this side plus n. So c equal to n divided by 2n minus 1. If we divide it by n in the numerator and denominator, it will be like 1 by 2 minus 1 by n. So if n is greater than or equal to 1, for example, if n is 1, 1 by 1 is 1, 2 minus 1 is 1, 1 by 1 is 1. So C will be 1, which we are getting a positive number. So we are saying for n greater than or equal to 1, we are proving that t of n is less than or equal to cn square. So this is one sum. Another one I explained is t of n equal to c plus t of t n by 2. So first step is to guess the goal. So since the sum is having n by 2, the guess is like order of log n. So our goal should be t of n less than or equal to d log n. Is c or d anything can be common. In the above sum we used c n square. Here we are using d log n. So our induction hypothesis t of n by 2 equal. So our goal is to prove t of n. In problem we have t of n by 2. If t of n is d log n, then t of n by 2 is d log n by 2. Proof of indexes, we are going to apply this t of n value in our problem. So it will be a d plus, okay, since in problem we have c, then that's why we assumed our induction goal is d log n. So c plus d log t of n by 2 is d log n by 2. Uh, Anything like log a by b means the formula is log a minus log b. So log n by 2 is log n minus log 2. So we wanted to prove, so we have d log n plus c minus d. Why we are, when we multiply this d log n inside, we'll get d log n and minus d log 2. So log 2 value is 1. So we have d log n minus d plus b. So we wanted to prove t of n is less than or equal to d log n. So we wanted to say minus d plus c should be greater than or equal to 0. Then only we can prove that t of n is less than or equal to d log n. So if this is true, then c, this minus d will be plus d this side. C should be greater than or equal to d. When c is greater than or equal to d, then uh, this formula will work. So why I am written? No, I think we can follow this one only. So when c is greater than or equal to d, our thing is working. In the notes I shared, algorithm notes till number 3, there we have these two problems explained by sir. So use this for a reference. In another video, I'll explain the master's method and subtree method also. Thank you.